Welcome and thanks for joining us today. As a value-added component distributor, Elektronika offers our customers the design resources to build their solution. Our optimized designs helps our customer reduce their design build time, risk-free development, and quick turn from prototype to production build.
Hi, my name is Mike Matthews. I'm the VP of Product Development here at Power Integrations. And today, I'm going to be talking about a new product called MinE-CAP. So maybe the first question is what is MinE-CAP and what does it actually do? Well, MinE-CAP is a very novel and unique solution for shrinking the size of AC/DC power supplies. And it does that in a unique way by shrinking the size of the input bulk capacitor, which is the input stage of the power supply. And that's not something that anyone has done previously. If I draw the input stage of a typical power supply, you have the AC here, a bridge rectifier, and the very first main component after that is what's called the bulk capacitor. And the bulk capacitor is the energy storage element at the input of the power supply, which filters and reduces the ripple from the AC coming through on the input side. And this capacitor is a very large part of the overall size of the power supply, often about 25% in a small adapter. Now, the challenge with this capacitor, in terms of choosing it, is that when you have a universal input power supply, the input voltage can be anything from 90 volts to 265 volts AC. And that translates on the rectified side to something like typically about 100 volts to 400 volts on the DC rail, depending on the size of this capacitor. So what that means is that this capacitor has to be chosen to accommodate or work reliably from a 400 volt, so it has to be at least 400 volts in rating. But the storage capacitance that's needed is the highest when the input voltage is low. And therefore, the number of microfarads of capacitance is governed by the low voltage. So the challenge the power supply designer always has is that he has to choose a capacitor with enough microfarads to filter effectively the input waveform, but he has to also select the voltage of the capacitor to be at least 400 volts. And it's that combination which makes this capacitor so big. Now, what the MinE-CAP does is it removes the need for a very large high voltage capacitance, and instead it replaces this input capacitance with a much smaller value, 400 volt capacitor. And that capacitor is designed so that the power supply operates correctly at the high line input condition. And in parallel to that, a much larger value in terms of microfarads, but a much lower voltage capacitor, which goes in series with our new MinE-CAP IC. So here's the MinE-CAP. So the beauty of that is that this capacitor, which is only rated for 160 volts, is dramatically smaller than the equivalent 400 volt capacitor for a given number of microfarads. And as a consequence, of course, the input stage of the power supply shrinks. In actual fact, a 160 volt capacitor for the same value of microfarads as the 400 volt is roughly about a third of the size, third of the volume. So in terms of the overall input stage of the power supply with these capacitors, it's about a 50% reduction in the capacitor volume. And amazingly, in some power supply designs, that can translate to up to 40% of the overall power supply design size, because these capacitors are so large that they tend to be very difficult to position in the power supply enclosure. And they have, therefore, a disproportionate impact on the overall volume of the power supply. For more information on MinE-CAP and to find out exactly how it allows us to use smaller low-voltage bulk capacitors, please visit us at www.power.com.
Thank you.